Jenny, have you ever explored Utah's landscapes? They're absolutely mind-blowing. The red rock deserts in Arches, Bryce Canyon, Canyonlands, Capitol Reef, and Zion feel like stepping onto an alien world.
Oh, Charlie, I've been there. It made me feel like I had stepped onto another planet. Utah's scenery is like a massive geologic scrapbook, with each rocky layer preserving a chapter of Earth's history. Over a long period of time, nature sculpted those vibrant red rocks that draw adventurers and geologists from around the world.
Well, it never fails to charm travelers from near and far. Those deep red rocks in southern Utah. They are iconic for a reason. The vibrant colors come from iron oxide. Specifically, a mineral called hematite. It coats the rock layers in shades of red, maroon, and brown, creating that jaw-dropping look.
Yeah, it's like the Earth turned artist, painting these landscapes with bold, fiery hues. The way those colors pop against the desert sky is unforgettable.
Totally. Take the Fisher Towers, for instance. These incredible spires rise dramatically from the ground. And if you look closely, you'll notice they're made of different layers of rock. The lighter rock underneath and the darker rock on top. And each tell a story of how the land has changed over a really long time. These towering spires are made from the Permian Cutler Formation, capped with darker sandstone from the Triassic Moenkopi Formation. It's like reading the Earth's own history, written layer by layer.
It's mind-boggling to picture it today, Charlie. Way back, in deep time, much of Utah was covered by a vast inland sea. Sound unbelievable, right? Sand, mud, and thick layers of salt slowly settled on the sea floor. Over time, these layers tell the story of seas advancing and retreating, deserts spreading, and rivers carving their paths. In places like the Paradox Basin, evaporating water left behind enormous salt deposits.
Exactly. What we see as red rock today was once part of a dynamic underwater world. The layers of sand, mud, and salt shifted and flowed over time, slowly shaping the landscape over many years.
And these layers didn't just stay put. Tectonic forces buckled and cracked the Earth's crust, pushing some areas upward into cliffs, mesas, and spires. But that was just the beginning. Once the land rose, wind, rain, ice, and flash floods started carving the rocks. They shaped deep canyons, elegant arches, and towering spires. Every groove, ledge, and color in those layers tells a story of ancient climates, shifting rivers, and relentless erosion. The contrast between hard and soft layers created those iconic shapes, arches, fins, and jagged towers that seem to defy gravity. Walking through these landscapes, you feel the immense timescales and nature's patient artistry.
Right. It's like the Earth sculpted these formations over an unimaginable stretch of time. Speaking of the Paradox Basin, have you seen NASA's recent Earth observatory images? Their satellites captured stunning views of the salt deposits from space. Well, the basin is massive, stretching across southeastern Utah into western Colorado, with thick salt layers buried deep underground.
Yes, I did. Those images are incredible, Charlie. I can't imagine seeing such ancient geology from space. You can't see the salt directly, but the way it shapes the land is striking from that perspective.
Exactly. The salt is buried thousands of feet down, but its movement creates salt anticlines and salt domes. These underground shifts push and warp the rock layers above, forming unique ridges, valleys, and collapsed basins visible on the surface.
In NASA's images, especially around Moab and the Colorado River, you can see the contrast between reddish-brown sandstone and lighter eroded valleys. It's like the Earth's surface carries the fingerprints of ancient seas, visible from hundreds of miles up. That's so fascinating. I'd love to study those patterns myself.
They're stunning. You can trace where salt movement has shaped the landscape.
It's amazing how satellites reveal so much about what's hidden below. Those patterns are like a geologic puzzle. But is there a way to know if the Paradox Basin's salt layers are still moving today? And can satellites confirm the salt's presence without digging?
Great question. Yes, scientists can detect both the salt and its movement without drilling. They use INSAR, interferometric synthetic aperture radar, to measure tiny changes in ground height, sometimes just millimeters, caused by shifting, swelling, or dissolving salt underground.
That technology is incredible. So, what about detecting the salt itself? I'm guessing satellites can't just see it directly, but they must pick up some clues about what's down there.
You're right, Jenny. They can't see through the rocks. It's not like glass. But they detect indirect signs. Geological mapping, gravity surveys, and seismic imaging are key. Salt has a different density than surrounding rock, so gravity measurements from aircraft or satellites hint at its location. Seismic surveys use sound waves to create detailed pictures of underground layers, confirming the salt's depth and thickness.
That's such a powerful combination. Satellite radar, gravity data, and seismic surveys, all working together to map the Paradox Basin without a single shovel. It's like blending cutting-edge tech with classic geology to unlock secrets hidden for millions of years.
It gives us a clearer picture of this hidden world.
And that same technology probably helps uncover valuable resources, doesn't it? Utah's rocks are more than just beautiful. They're a treasure trove of history and wealth waiting to be explored.
Absolutely. Utah's underground is packed with resources. Mining has shaped the state for over a century, from copper, gold, and silver, to uranium, molybdenum, and even the rare beryllium. Utah is one of the top metal-producing states in the U.S. Mining contributes billions to its economy. Modern technologies like satellite radar, gravity surveys, and seismic imaging now help geologists pinpoint these resources more efficiently and safely. These technology reduce the need for trial and error digging. It gives us a clearer map of where valuable deposits lie.
That's incredible! It really shows how deeply Utah's history and economy are tied to its natural resources. I'm curious, what's the latest on resource exploration? Are scientists still searching for new deposits? And where are they focusing their efforts?
They're definitely still searching. A lot of focus is on the Great Salt Lake Basin. Teams are using geological and geophysical surveys to explore the lake's mineral potential, especially lithium, magnesium, and potassium. These are key for batteries, fertilizers, and industrial uses.
For sure. These minerals are basically the secret sauce behind EVs, fertilizer, and tons of cool tech. We're talking about the building blocks of modern life, powering cars, growing crops, and cutting-edge gadgets.
The surveys are still happening. But one thing is clear. The Great Salt Lake is loaded with minerals. In fact, magnesium has been produced commercially from the lake for decades. A company called US Magnesium, basically the main magnesium producer in the United States, even became the country's top producer. And they extracted magnesium straight out of the Great Salt Lake brine.
That sounds promising. Those minerals are so critical today. What methods are they using to uncover these hidden treasures? And how do they balance that with protecting the lake?
They're sampling brines, mapping sediment layers, and using satellite data to track changes in water and mineral concentrations. These studies help Utah plan resource management. At the same time, they protect the Great Salt Lake Basin ecosystem. And that is vital. Do not forget Jenny. It's not just a resource. It's a cornerstone of wildlife, climate, and tourism.
Lithium is huge right now, especially for electric car batteries. How far along are these surveys? Are we close to large-scale extraction of lithium from the Great Salt Lake, or are there still hurdles to overcome?
The main hurdle is extracting lithium efficiently and responsibly, without harming the delicate ecosystem of the Great Salt Lake. Surveys combine chemical analysis, hydrology studies, and pilot projects to test feasibility. The potential for lithium extraction is huge, especially with rising battery demand. But Utah is prioritizing the wildlife, climate, and tourism.
Utah's landscapes are so much more than stunning views. They're alive with stories stretching back millions of years. From red rock cliffs shaped by ancient seas, to hidden salt layers and valuable minerals. Science is uncovering new chapters every day. It's a reminder that our planet is always evolving, and the more we learn, the better we can protect and cherish these incredible places for generations to come.